Alright, so untuk soalan nombor 20 ni, okay, so you have to find which statement is true to find dy dx. Okay, if given ax square plus 2hxy plus by square equals to 1. So basically soalan ni minta kita cari dy dx over here. Right, so to find dy dx, okay, so these are few statements that are given. So basically these are the steps yang dia bagilah untuk kita solve. Okay, untuk kita nak dapatkan dy dx tu. So let us check if either all of these statements are correct. So let us try to perform this calculation. Okay, so we have over here, so to get dy dx, remember that we have to do implicit differentiation here. So kita buat differentiate each term with respect to x. Alright, so we are going to have here, so starting from ax square plus 2hxy plus by squared equals to 1. Okay, so taking d dx for the whole equation, for the whole term. So kat sini kita akan dapat 2ax, alright, so d dx of the first term, and then for this one, you have 2h, and then notice that over here, okay, xy is in a product, right, so you have your u is equals to x, your v is equals to y, so u prime is 1, v prime is dy dx. Okay, so what we're gonna have over here is substitute here. Okay, so y plus x dy dx over here. Alright, and then for the next term we're gonna have plus differentiate y square, we're gonna get 2y, okay, so 2by over here, and then we will have our dy dx. Right, so on the right hand side that will be a 0. Okay, so after we've completed this, so we try to combine, or we collect the like terms. So for the term of dy dx, we have 2hx, okay, so 2h and then x over here, and then we also have 2by, okay, plus 2by, and that is dy dx. Alright, so put that in bracket, and then we take the other two terms to the right hand side, so we're going to have negative. Okay, so here we have 2ax, okay, and then if we expand this, we're going to have plus 2hy, so negative of both terms. Alright, and then the next step is dy dx is equals to negative 2ax plus 2hy, okay, and then divided by 2hx plus 2by. Okay, so if you notice over here, all the terms we have that term of 2, so we can actually divide that. So we will have here negative ax plus hy, okay, and then divided by hx plus by. Okay, so after we've got to this calculation, then you check lah over here from all these statements which one are true. Okay, so if we check over here, the first line we have 2ax plus 2h, and then we have x dy dx, okay, and then y, okay, and then we have plus 2by dy dx. So statement number 1 is correct, right? Statement number 2, we can factorize this. Okay, this is our next line, so number 2 is correct. Okay, and then if we check for statement number 3, this one we have 2by dy dx, okay, this is the positive one, and then negative 2ax plus, okay, so this one should be a minus, right? So when we factorize this one, this is a positive inside, so if we expand the bracket, this one should be a negative, and then for this 2hx also should be a negative, so the third one is not right. And the last statement, number 4, this is what we've got to the last line, so number 4 is also correct, that's why the answer is B. Alright, so that is for question number 20. So we look at the next question, question 21. So for question 21, now we have to check for which statements which are correct. Okay, so kalau kita tengok dekat sini, first is f of negative 3 defined. Okay, so let us check that f of negative 3, so that is equals to 0. Okay, so if we check from our functions here, so that is equals to 0, so it is defined. Okay, so defined. Right, and then the next statement is the next two statement is we check the value for the limit from the left hand side and right hand side. Okay, so let us check the limit for x approaching -3 from the left first. So from the left, the function is on top here, okay, which is x squared minus 9 over x minus 3. Okay, so this is the limit from the left. And when we check over here, the limit is, you have to factorize that first. Okay, kena factor kan. Okay, so this will be x minus 3 and then x plus 3. Okay, and divided by x minus 3. So we're going to simplify this. Okay, you're going to get, so -3 substitute over here. Okay, -3 plus 3, that is going to be 0. Okay, so this is the limit from the left. If we check the limit from the right of -3, okay, the function, our function is 2x minus 3. Okay, so just substitute our value. We're going to have 2 times -3 minus 3. That will be -6 minus 3. That is equals to -9. So if we check then, to check, because the last statement is about the continuity. So kalau kita check dekat sini, approaching -3 from the left, and the value for fx, okay, the value for the limit of x approaching -3 from the right of fx is not equal. Okay, so since if it is not equal, therefore fx is not continuous. Okay, so we understand that it is not continuous. Okay, so when you answer this question, because this is an objective question, so you don't really have to write down all the steps over here. But if you stop at this one, you already know that this fourth statement is incorrect. Okay, because it is not continuous, it is not the same. So f of -3 is defined, that is correct. The limit for fx, x approaching -3 from the left, is equals to 0 over here. Okay, so that is the third statement. The second statement is not right already. Okay, and the limit of -3 from the right is given by -9. So we have that the first and the third statement is correct. So the answer here is question B. Alright. Okay, so for question number 22 over here, alright, this one is a bit long. Okay, so I'm gonna stop here. Okay, so over here we have question number 22. Right, so for question number 22, we have this two equation given y and also x. Okay, then we have to find the value of t when 1 minus dy dx minus the second derivative squared equals to 0. Okay, so first, when we have these two equations, let us take this out first. Okay, we have y is equals to exponent t plus exponent -t plus 2. Okay, so we can get our dy dt. So dy dt is equals to exponent t minus exponent -t. So if you rearrange this, that will be exponent t minus 1 over exponent t. Okay, and then we have the second equation. We have x equals to exponent -t plus 2. So our dx dt, okay, so our dx dt is given by -e -t. Okay, so this one is dx dt. Now to get to our, so in our equation that we need to prove here, we need to find our dy dx and also the second derivative. So first, let us try to find our first derivative. So dy dx, okay, is given by, we have to differentiate this. We're gonna get dy dt times with dt over dx. So we need to get dt dx. Over here we have dx dt. So dt dx is basically the inverse of this. So if just now we write this back in terms of fraction, that will be -1 over exponent t. So dt dx over here will be just negative of exponent t. So substitute these two value of dy dt and dt dx in our chain rule over here. So dy dt is exponent t minus 1 over exponent t. Okay, and then we have to multiply with negative exponent t. Okay, so multiplying this, if we simplify this one first, we're going to have e exponent t minus, sorry, this one will be exponent 2t. Okay, so equalize your denominator, minus 1. Okay, and then over exponent t times with negative exponent t. Okay, so we will have that our dy dx is equals to, we simplify, we're going to get 1. Okay, we're going to have 1 plus with, sorry, 1 minus with, because we expand this, 1 minus exponent 2t over here. Okay, so you have to expand this term first. Okay, expand these two terms and then you divide by exponent t. So we're going to get dy dx equals to 1 minus exponent 2t. Okay, so for our second derivative, what we're going to need is, okay, so you have to check your second derivative, you will need our, okay, so let's do the second derivative on top here. d2y over dx squared, you have to differentiate again, sorry, d dt. Okay, you have to differentiate again our dy dx, dy over dx, and then you have to multiply with dt over dx. So this is the chain rule for the second derivative, right? And then what we're going to have here is differentiate our dy dx. Okay, so dy dx is given by 1 minus exponent 2t, and then times with dt dx, which is negative exponent t over here. Okay, so differentiate this, we're going to get negative 2 exponent 2t. Okay, and then times with negative exponent t over here. Okay, that will give us 2 exponent 3t. Okay, exponent 3t. So in this question, we need to find our equation over here. We need to use this equation over here to get to the value of t. Okay, so by taking that, we understand that, okay, if we take if you substitute the information that we have in our equation, so we will have 1 minus, okay, so dy dx minus with our second derivative d2y over dx squared, okay, that is equals to 0. Okay, so substitute all the values that we have. Dy dx is 1 minus exponent 2t. Okay, and then our second derivative is 2 exponent 3t. Okay, we have squared over here. Squared equals to 0. Okay, so simplifying this, we're gonna get exponent 2t. Okay, and then minus with 4 exponent 60, that is equals to 0. So we're gonna have two values over here. We're gonna have, you can factorize this out, exponent 2t. So we're gonna have 1 minus 4 exponent 4t, that is equals to 0. So by taking this, we have two answers over here. We have exponent 2t equals to 0. So the answer is undefined. Okay, and then you will get that 1 minus 4 exponent 4t equals to 0. So by rearranging, you're gonna have 4t. Okay, so if we take ln, we're gonna have over here that, okay, let's take this one, exponent 4t is equals to 1 over 4. Okay, and then we're gonna have that t is equals to 1 over 4. Okay, ln 1 over 4. Okay, by taking ln on both sides over here, then we're gonna get the value of our t over here. Right, so the answer over here will be t equals to 4 ln, 1 over 4 ln 1 over 4. Then the answer is equals to question A for 22. Alright, so let's proceed to the next question, question number 23 over here. So for question number 23, we have that dx dt equals to, given by, so the side of ice cube is decreasing at the rate of 5 centimeter per second. Okay, so when it says decreasing, so the keyword over here is decreasing, right? So we can write down that dx over dt is equals to negative 5, okay, cm per second, because it is decreasing. So what we need to find is our dv dt. Okay, so basically we're going to check here that our v is given by 3x squared, so the volume of an ice cube, right? So ice cube is, if one side is x, then the value is given by, sorry, the value is x cube over here, sorry. So when you differentiate v, then you're gonna get 3x squared. Okay, dv dx will be 3x squared over here. Okay, so this is our dv dx. Now we want to find dv dt. So to get to our dv dt, we understand that we need to take out our chain rule. Okay, so dv, and down here we have dt. So we already have the information for dx dt. So down here also we'll put our dx. Okay, so dv dx is given by 3x squared times dx dt. So dx dt is negative 5. Alright, and then we already know that we want to find this rate when the side is equals to 20. So you boleh masuk directly 20 squared over here times negative 5. Okay, so you just use a calculator, and then you're going to get that the value for dv dt is equals to negative 6,000. Okay, so 6,000 cm cube per second over here, cm cube per second. So that is answer B for question number 23. Okay, so the next one for question number 24, the highlight over here is, okay, you are given this equation hx and also kx, alright, and you need to determine which of the following statements are false. Okay, so remember that we want to check for the false statement over here, not the correct statement. Alright, so what we're gonna do here is, because we want to check for h composite k, so we will do the composite function first. Okay, so h composite k of x is equals to, when you substitute the function of kx in your h functions. Okay, so that is given by modulus of 2. Okay, and then we're going to substitute kx over here. Alright, and then plus 5. Okay, so 2kx plus 5, and then substitute with the function of k, which is x minus 3, and then plus 5 over here. Okay, so dah substitute dekat sini. When you expand this, you're gonna get 2x minus 6 plus 5, so that will give you 2x minus 1. So this is the composite for h of k. Okay, hkx, composite h and k. Alright, so look at the next statement that we have, that is related to the domain and range, and also the graph of this function. Okay, since this is an absolute value function, we understand that the asymptote, or the minimum point, the vertex will be at 2x minus 1 equals to 0. Okay, so if we check from this one, 2x minus 1 is equals to 0, x is equals to 1 over 2. So actually this graph is correct. That is how we sketch our graph. Okay, we're gonna have it over here. Okay, so that we touch at 1 over 2. Okay, our graph here we touch at 1 over 2. And then because we want to also check if this is a one-to-one function, so we're going to do our horizontal line test. So if we take a line over here, so we can see that it touched our graph at 2 points. So it is not a one-to-one function. So we can already remove the statement. Sorry, not remove. We can already. Alright, so kita tengok soalan number 25, the last question. Alright, so this question is on rate of change. Okay, so the radius of the circle is increasing at the rate of 0.5. Okay, so the radius increasing at the rate of 0.5. So it is going to be our dr over dt. So because it is increasing, so it is going to be a positive 0.5. Alright, and then you have to find the rate of increase of the area. So dA over dt. Okay, so when the circumference, okay, so it's given the circumference, which is, we can name as C, which is equals to 25. So this is the focus over here for this question actually. So when C is equals to 25, you have to check back what is your formula for the circumference of a circle. So C is given by 2 pi r. Okay, so meaning that if we equate these two, 2 pi r is equals to 25. So our r is equals to 25 over 2 pi. Alright, so meaning that now we want to find dA dt when r equals to 25 over 2 pi. So let's come up with our chain rule for dA over dt. Okay, so to get your dA over dt, okay, so if you check your formula for your area, okay, area of a circle is given by pi r squared. Okay, so if we differentiate this taking dA over dr, we are going to get 2 pi r. Okay, so dA over dt, we're going to need dA, okay, and then times with down here dt. Okay, so we already have dr here, so dr is going to need what we need over here. Okay, so dA over dr is 2 pi r, so times with our dr dt is 0.5. Okay, and then you substitute r, because this is just an objective question, you can just directly substitute 2 pi, okay, and then r that we want is 25 over 2 pi. Okay, so when r is 25 over 2 pi. So we can simplify this. This one is times 0.5. So 0.5 is actually 1 over 2. And you will get your final answer 25 over 2. And this is area. So cm squared per second. Okay, so over here our final answer is B. Alright, 25 over 2 cm squared per second. So for this one, the trick is for you to make sure you get your value for r in this form, right? R equals to 25 over 2 pi.